Today we'll be solving equations with variables on both sides. So in order to accomplish this, we need a plan. First thing we're going to do is simplify both sides of the equation. We're going to apply the distributive property if necessary, and we're going to combine like terms. Once each side of the equation is simplified, we're going to move the variables to one side, and then we're going to move all the numbers or constants to the other side. So here's our first example. 8m plus 5 equals 6m plus 1. So I'm going to look at the left, and I'm going to look at the right and see if they're simplified, and they are. So I can move the variable. So minus 6m minus 6m is 2m plus 5 is equal to 1. Minus 5 and divide by 2. M equals negative 2. Try number 2. C equals negative 4. Try number 3. B equals negative 7. Try number 4. P equals negative 6. All right, number 5. So number 5, we have 9a equals 6 times the quantity a plus 4. So the left side of this equation is simplified, but the right side is not. It has parentheses. I need to apply the distributive property. So I'm going to do that. 9a is equal to 6a plus 24. Now that the right side is simplified, I can move the variables to one side. So I'm going to subtract 6a on both sides. So 3a equals 24. A equals 8. So go ahead and try number 6. And on number 6, h is equal to 3. Right, sometimes when we're solving multi-step equations, we run into two special cases. The first one is called identity, and the second one has no solution. So these are the two types of special cases when solving multi-step equations. So let's look at each of them. So let's go ahead and solve the identity one. Just going to simplify like we would on any multi-step equation. Well then, as each side simplified, we subtract the variable. So we get 6 equals 6. So if we go back to this step after we distributed, we can see we have 12x plus 6 equals 12x plus 6, which is an example of the reflexive property while we're here. And when we have this, that's why it's the identity. The variables zero out, and we're left with two constants. 6 equals 6. Since this is a true statement, 6 does equal 6, we know that the solutions are all real numbers. And the symbol for all real numbers is a big R. Let me change colors. All right, we take a vertical line, another vertical line, and then make an R. All real numbers, something like this. Okay. Another example is no solution. So again, like any multi-step equation, I'm going to simplify both sides. And once both sides are simplified, I'm going to move the variables to one side. And since this is a special case, the variable will zero out. And now I'm left with a statement that 2 is equal to 10, which we know is false. We know that 2 is not equal to 10. So since it's false, it's no solution or empty set. There is no number we can put in for that variable to make this a true statement. So those are your special cases. So we need a little more practice with the multi-step. So here's a big one for you to do. So go ahead and practice this. Write this in your notebook. And x equals 7, 6. And our last example for today we'll call the granddaddy. Again, do this one in your notebook. And x equals -5.